All right, good morning, everyone. Let's start here. So, a few notes before we get into the new content. I made a post on Piazza a while ago, I want to say a week ago, for a note taker. There's an opportunity for a note taker in this class. If you respond to that, contact accessibility resources. They haven't had any responses on that, so if you are interested, maybe you're thinking, well, somebody probably already took that opportunity. It is still available, so if you're interested, taking notes in this class and submitting them to accessibility resources, it does pay, so you get paid to take notes. It's something some of you are doing anyway. If you're already taking notes for the class, get some extra cash in your pocket. If you're interested, either contact me or find that post on Piazza, and let's fill that position. Right here. I also posted about the project team formation. So team formation, you have to be in a team by the end of class on Friday. So Friday, I purposely made the deadline right at the end of class. So if there's anyone who's not in the team before Friday's lecture, I don't know, I might call you out during lecture or something. Something during lecture, we'll get together and get everybody in a team. If you have your team known already, fill out the project team formation link here or on Piazza. Form your team, just let me know who your teammates are. Teams, reminder, have to be 3 or 4 students. If you want to be placed in a random team, submit the form, just say there's an option to just put me in a random team. Random team, and that's it. Or choose your teammates, and the form doesn't want to respond right now. Or my laptop doesn't want to.
Yeah, I submitted the form saying I want to be the random team, and then I joined the team and submitted it again. Is that okay?
Yeah. Send me, can you
posted on Piazza.
Can you send me an email to just with a link to the Piazza post, the title like not random team anymore or something like that, just so I don't accidentally put you in a team. Is this form not responding though? Oh, and then next, you get the idea. But information by Friday. Meetings start next week. By next week, find a time to start meeting with your team. And then after each meeting, I haven't really talked about this form. I won't go through in great detail, but fill out this form with all the information. You'll have to set up a GitHub repository. I'll ask for the repo links as we submit phase 1 of the project. Bless you. And after each meeting, you should have some way of tracking your tasks and give links to any tasks that you are going to work on throughout that week before the next meeting. So you can use anything you want. I recommend just GitHub issues. It's effective, it's simple. If you want to use Scrum boards, if you're savvy to that stuff, especially if you've taken 442, I'd recommend following the Scrum model, but if you don't know what that is, obviously not. But fill out your tasks, however you're tracking them, and give descriptions of what you've done each meeting, and everyone's favorite, peer evals. So the peer evals, usually in a lot of courses, and I've taught 442 quite a few times now. There's a lot of different ways to do this. Usually they're after each submission, and that tends to just not work very well. So I'm going to ask for some feedback on every single meeting. How are your teammates doing? This isn't going to directly affect the individual grading after every single meeting. I'm not just going to take these raw numbers, do some math, and spit out some individual grading. But I will take these into consideration, especially if there is an issue that arises. I'll look and say, well, you don't have many commits in GitHub, and you skip 2 meetings. Well, it's easy for me to make a decision to split up the grading at that point. So I just want to know, just keeping track of letting me know how the team is working, how effectively your team is working together as a team after every meeting, so having weekly updates on that. So hopefully that'll give us more meaningful feedback. And exactly when an issue arises, it's always this problem where somebody's great for half of the submission, like a 3 or 4 week submission. Somebody's great the first 2 weeks and then just really trails off the second 2 weeks. Well, how do you fill out one peer eval for that? What if they were really great the day before the deadline, but really sucked the rest of the time? How do you put that in a peer eval when you just got to give them a score? So weekly, every week, let me know how they're doing. Give me a better idea and give me a better way to address certain situations that always come up towards the end of the semester. So with that, any questions on that? I think that's fairly straightforward, but if it isn't, please let me know. Okay. And then any final individual grading decisions will be made by me. I'll reserve the final judgment on that based on what I hear from the teams, based on what I can see from the repositories, what it looks like the effort is. And the average score of your team will be exactly the team grade. So it's a zero-sum game. I'm not going to just say this whole team did bad and lower everybody's score or anything like that. So I just want to distribute the points and reward the students who did put in the effort to complete the project. That's my ultimate goal. So to that end, give me the information that I need to make those decisions. Yes?
So, one question I had was I know you listed like the requirements we need to hit for the project. Is it the idea that if we just hit the requirements, like that's 100, or is the idea that like we also need to make something like kind of special and cohesive?
For each submission, I'll have like more specific criteria, but as long as if you do build a project that meets those 5 bullet points, I mean, the most extra that you have to do is just what are the logistics of how to submit and things like that. For example, I do want to talk about what phase 1 is. But if you build a project that meets these 5 criteria, there's really no reason for me to take away points. Because as long as you build some and nothing's like shortcutted in there, like technically we have user accounts, you know. If you have the spirit of user accounts according to this, then that's fine. That's good. I'll give more details on each submission. With phase 1, I'll get the more detailed criteria soon. I was hoping to do that by today, so. But the general idea is phase 1 is going to be building your front end, building the HTML, CSS, JavaScript, everything that's going to be seen by your user, but without any functionality on the back end. No functionality required. So you don't have to have a database hooked up. You don't have to have the server responding to button presses, responding to forms and things like that. But you do need to have a server hosting your front end. So this is going to give the look and feel and the user experience of your project. That's what you'll be building for phase 1. So if you're getting started, especially in your meeting next week, you're getting in there, you're starting the code, think about the front end, think about the HTML, think about the theme. What is your website going to be? I had the 5 bullet points there, but the bullet points are very broad, very general. I wrote those in a way that it can incorporate any ideas that you might have within reason related to social media. So any social media site your team thinks of, you say, I want to make this, I want to make Facebook for puppies, or whatever your idea is going to end up being. Those 5 bullet points aren't going to restrict your idea. You shouldn't be saying, oh man, we can't do that because it doesn't meet Jesse's criteria. Any social media site you come up with should fit into those 5 bullet points. So start thinking about that and building that front end. What do you want the site to be? And the next 2 phases are going to be actually building the functionality on the server side. So phase 2 is going to be building all of your features, uploading posts, making comments, likes, basically building all of the functionality of the website, but without any users, without any user accounts. Then phase 3 will be adding authentication and user accounts to that. So after phase 2, anybody going to your site could make a post, could make a comment, and it won't be necessarily attached to them. It'll just be somebody made a comment. Basically, like everybody's anonymous and everybody's the same single user. And then phase 3 that's where you're adding the user accounts. Okay, this person made a post. That's where you're adding the friends list, follows, or whatever you end up doing for that part of the criteria. So front end, functionality, then user accounts. That's the general high-level overview, so if that helps your planning. And then as we get to each phase, it'll be documents that say, this is exactly what we're looking for phase 1. What do I mean by front end? What has to be there? Which will be most likely the 5 bullet points. It has to be clear where each one of those comes into play from that GUI. So if there's image uploads, there should be a button that says, click here to upload an image. Just something showing like how is the user going to do the things that you expect it to do. And and a write-up of your idea will be part of phase 1. Does that make sense? Anyone have questions about that? 'Cause I know what I want to do for these phases, I just haven't written up the docs yet. So if there are questions that can help you get started, please ask them. Yes.
So like, would this include like the pages for the, like a possible user hierarchy, like an admin? Cause like, for like Twitter, there's like the admins who can remove accounts and stuff like that, would you want that in the?
So the question for Twitch, do you, for phase 1, do I have to have like the admin pages and things like that? So an admin page isn't a requirement of this. If that's part of what you want to do for your project, by all means, but that's not one of the 5 bullet points, so technically you don't have to have that feature. If you want to add that feature, all the better. And you could probably make that feature count as one of these 5 bullet points. Maybe the friends or follow, like if you can make an admin and then that person is able to do different things to your content, like that would count for this bullet point. As long as you have some way of a user being able to mark another user as something and then something different happens based on that, that'll count for this bullet point. So that would count for that bullet point if you want to build that. But that specifically, having an admin side to things, isn't a requirement of this project. It's something that should exist in production if you're building this thing, but it's not a requirement for this project. Any other questions on this? Yes.
Will you have any suggestions for each one of the phases regarding task division between group members?
Not specifically. I'm going to leave that up to the groups. So every situation is going to be different. I mean, I'll get the general recommendations. I mean, try to design your site in a way that you can split it up. Whether, try to encapsulate your functionality into separate parts of the project, whether it be classes, functions, whatever paradigms you're using to design your code. Try to split it up so you can work in parallel and then divide that work. Don't try to just build one big monolithic, one huge main method with all of your code. If you're doing that, it's really hard to split up that work. So encapsulation, really all the best practices, the kind of stuff we learned in 1.16, all that should come back. And I'll talk about homework 4 in a minute. I'll bring that up there as well. For your homework, you should be using those best practices too. But I don't have anything more specific than that. Encapsulation is your best friend when you can divide up the work. You write a function named this that takes these parameters and returns this. I'm going to call that, expecting that it's going to exist at some point, and then you can start working in parallel that way. Yeah.
What happens if we finish starting pages like early, or if we do them together?
Yeah, by all means. Yeah, if you finish, like if you want to build your whole site right now and just deliver that for the phase 1 and be done with it, I don't have a problem with that. You might have to do specific things just for each submission. Like if I say, give me a document explaining your design or something like that, you have to generate that content. Yeah, you can be done with things early. There's no worries about getting ahead. And you can always work on it more. It depends what you're asking for. If you want to be just done with the project early, yeah, you can pretty much do that. If you're worrying, okay, I'm done, and what else do I do now? You can always expand features and go beyond that required feature set. All right, we got any other project questions? We gotta keep moving, but I realize these are important questions because you gotta get started with your teams. Okay, homework 4. Homework 4 is posted. This homework is not to be taken lightly. This is a pretty good jump up in difficulty. This is where your, I don't know exactly how to word this. I was thinking of how to word this, but this is pretty much, in my opinion, a make or break assignment. Like the difficulty was moving up quite a bit from 2 and 3. Not significantly so, But that statement's only true if you have good design and really understood what was happening in homeworks 2 and 3. If you were barely squeaking by homeworks 2 and 3 and didn't have great design with your server, adding these features might be a ridiculous amount of work, a ridiculous jump up from homeworks 2 and 3 because you're refixing your design from those assignments. If you do have good practices like encapsulation, like I was mentioning, if you have a method that extracts headers, for example, and puts them in a key value pair, whatever key value pair data structure you have in your language, and maps those header names to their values. If you have that built already, which you should because you're dealing with the cookies, or at least by Friday, when you're dealing with the cookies, let me say that, when you're dealing with the cookies, if you haven't built the cookie functionality yet, make sure you write that method that reads all of the headers, puts them in a big key value pair data structure, so you don't have to worry about that code again. Or else when you get to this assignment, you're going to be writing that. You're going to be reading those headers, or trying to write some big spaghetti code that looks for each specific header. That can be a mess. Some of you are getting away with that with cookies. I don't recommend that. It's going to catch up to you. Any bad design, and this is stuff that applies in general with software. Any bad design decision that you make early on is going to catch up with you. And as we keep adding more features to this server, it's going to start catching up. And this, in my opinion, is the assignment where all of those decisions are going to hit you very hard as you start trying to go through this one. If you have good design decisions and you really built a solid foundation in homeworks 2 and 3, it still won't be an easy assignment, but it won't be too bad. But if you don't have that solid foundation, this one's going to be pretty tough. So that's my fair warning. Don't take this homework lightly. The document itself looks unassuming enough. It looks like the other homeworks. Don't let that fool you. There is a lot going on here. So just be warned, start early, all the usual things that you hear all the time. Start early, get the good idea of what's going on, what this homework is asking for early. Because if you just glance through this, it really does look unassuming. Don't let it fool you. And at this point, if you do realize, I wrote this in here specifically because if you do realize your design decisions are pretty bad, pretty poor, and it's catching up to you, feel free to switch languages too at this point. Feel free to switch libraries, whatever's going to help you get through, help you get a solid server to be able to build upon for the rest of the semester. So feel free to scrap what you have if you realize, okay, I'm just going down a bad road here. And if you do, you don't have to rebuild the functionality of homeworks 2 and 3. You only have to deliver this functionality. So ideally, in theory, in a perfect world, by the end of the semester, end of homework 10, you'd have all these features in one big server. I realize that's not always going to happen. So for each homework, I'm only looking for the objectives of that homework. I'm not looking for that big server with all of the features. So take that for what it's worth, if that helps you out moving forward. All right, so what is this thing asking you for? A text form. This is what we'll start talking about today. A form where the user can input 2 values. Actually, change this. It doesn't necessarily have to be, I'll leave it as texting. But just 2 values they have to be able to submit. It can be text, it can be numbers, it can be checkboxes, it can be radio buttons, but just something for a user to submit 2 pieces of information to your server, save those values to a file, and then host that file. So right here, there's quite a bit going on, and I should mention a lot of 115, 116, 250 topics are going to start flashing back. If you're not solid on all of those concepts, these will come back to you. File I/O, at a 300 level computer science course, I just take that for granted. You can do file I/O. I just assume that. So if that's not true, you got some catching up to do. Not the end of the world, but you do have to do that file I/O. So get 2 inputs, save it to a file, and then host that. So there's a lot of implications here of how to be able to handle that. There's a lot going on just in the first objective. Image uploads, add another form where users can upload images, save those images on your server, on your machine, and then post those images as specific path names. So for example, /image, where did I put it? Oh, it's objective 3. And so half of the homework is the image stuff. And then host those images, for example, /image/image name. Host those images at those paths, or any way you want to do it. If you want to add a query string, which tells you what file to serve, that's fine too. But any way for the user to be able to request an image and get that image. And then finally, probably the most unassuming, just one sentence, but build a page that displays every image that's been uploaded. And the same 3 submissions. Quick PSA, make sure you make all 3 submissions for the homework. There are, I believe, 10 students who didn't fill out the self-grading form for homework 2. If that includes you, nobody, we haven't started grading yet. We'll let that slide. Fill out that form now, it's still open. Make sure you get that done. But yeah, without the self-grading form, and there were 2 students who did that for homework 1 as well. For the early homeworks, if it's only the self-grading form, we're letting it slide on the early homeworks. Just make sure you make all 3 submissions. We'll just make the 2 auto lab submissions. With that, any questions about this homework assignment? Anyone starting to let all the implications of this sink in? There's a lot going on here. All right. Without further ado, let's start showing you how to get through that homework. So my job in 3 lectures, 2.5 lectures, is to get you to the point where you can do that homework. So let's start talking about it. Let me make sure I got all my notes here. Meetings start next week, team form, homework 4, submission 1 details. In the hosting, you can, obviously the project, all that stuff applies that we talked about day 1. You can use, you want to use, wow, I'm blanking. You want to use Express, Django, Flask, thinking on the other ones. But any front end, any web framework you want to use, it's all on the table for this. Just write up a report for each library or framework that you pull in or service that you pull in. You don't have to host, when I say hosting, I don't mean host it live on the internet, but you have to have the code for some server built that the TA and I would be able to run on localhost and then serve it up like that. So like your homework, but you don't have to build it from scratch. It has to have the ability to be hosted on the internet. It doesn't have to be actually deployed on the internet though. Yes?
So does that mean if you have a database, it should just be like a local file on the machine?
Yeah, for phase 1, you don't have to have a database yet.
Okay, but eventually, like I'm saying, like if it can just be hosted on a local machine, does that also mean that the database can be hosted on a local machine?
Yes. We'll have more details. So to come, I should mention this one. For all 3 submissions, even submission 1, we'll be using Docker to deploy these, to package these. So we should be able to just run your Docker and have a spin up. You can use Docker to spin up an instance of MySQL. Like you don't have to have that hosted on a separate service. Maybe that's what you meant. You don't have to have your database hosted on a separate server.
Yeah.
It can all be packaged in one place. Yes. All right. Let's work with some forms. Any other questions? All right. Let's work on some forms. So here is an HTML form, and what we want to start doing this week, and of course, as the entire homework implied, the users send us information. We did this only just briefly, just a blip at the end of last week, where they could send us query strings. That was kind of a little taste. Okay, they can send us some information through the query string in the URL, but that starts to get limiting. Do we have them manually type URLs? Do we have them, do we build links, custom links for them that with the query strings already built in? I think there's not a whole lot we can do with that. So let's start building forms so they can have more versatility in the information that they can send us. So let's look at this form. And this form will be up for a while. We're going to look through this piece by piece. So let's look at this form and see how users are going to send us information. And with these HTML forms that we're going to see, every time a user submits a form, it is going to cause a page reload. So when they submit this form, they're going to send a GET request to /form-path. So the form is going to specify which type of request and what path is going to be sent. This information is going to be sent to. So we've specified that right in the form itself. The action is going to be the path. This is the path that's being requested. And the method, get or post for our purposes, actually I think for all purposes for HTML forms, I don't know if there are other valid methods for these forms, is going to specify what type of HTTP request is going to be made when this form is submitted. And it's just like clicking a link. When we submit this form, it's going to make that HTTP request with that method to that path, just as if somebody typed that in their URL. It's going to make a request, get a response, and reload the page with that new response. So the response from a form should be HTML to load up the next page that the user is going to see. Next we have our inputs. The input element in HTML is going to be where users can interact with the form. How do they input data into this form? How are they going to interact with the form? That's going to be the inputs. This specific input is going to be a text box, so we use the type to say what kind of type of input this is. And there are lots of types. We'll talk about a couple of them at the end of these slides. But as always, W3 schools, the internet, there's all kinds of different types. From date pickers, color pickers, and they're all built into the browser. You can have the defaults for all those. So you ever see a site where it says choose the date, you click it and a calendar comes up? You just do type equals date. That's it. You can build fancier ones, and there are libraries for prettier looking ones. But if you just use the standard input, you'll get the default for that browser's date picker. It'll just pop up. All you gotta do is type date. I'm pretty sure it's date. Maybe it's date time or something like that, but something to that effect. And then the name. This name is very, very important. Name is what this value will be named when this request is sent to the server. So when we get this on the server, we're going to get some form of key value pairs. We're going to see a few different ways of getting this information. But we're going to get some key value pairs, and this name in the HTML input element is going to be the key for that value, and then the value is whatever the user put into this input. So whatever they typed in this text box is going to come to the server as the name commenter, as a key value pair, or the key commenter, and the value, whatever the user put in. So these names are so important. This is how we're interacting with the server. This name is what connects our front end to our back end. That's how if the name matches on our front end and back end, that's how we're getting the correct value. So the name, critically important here. And it's always good practice to have a label for every single input, or except the buttons have the value. But for everything that needs a name, like we could just have maybe paragraph text, or just no HTML elements at all. We could just say enter your name, colon, and then the input. But if we do a label, that's going to associate this text with our input. And we do that by ID. So the ID of an element, recall that these have to be unique. So we give our input a unique ID, and then give it a label and tell it what ID element this label is for. And that's going to link that text with that input. So now this enter your name, of course I physically placed it next to this text box. So a user looking at it is going to know they're associated. But also now screen readers, importantly, are going to know that this label is for this text field. So if a blind user is using this site, and they are tabbing through, and they have that text box selected, their screen reader can read to them, this is what this text box is for. So they're not going to see how the text lines up visually, obviously, but they can still be able to tell what information this specific text field is asking for. It's going to read enter your name, and they're going to know what to put in. So important for accessibility. Also, when you click on the label, the associated input is going to be selected. So you ever see a form with radio buttons, and you click on the button, of course, it selects the radio buttons, or the circle of buttons where you can only have one selected. But if you click on the text associated with that input, you don't have to click the button itself, you just click the text next to it. Super convenient, and we're kind of used to that. We kind of expect that behavior these days from our forms as users. If you have the label associated with that, you'll get that behavior. If you click the text, enter your name, it's going to select that text box on my form. So important to have the labels. It's best practice to have those on there. It's going to give your form more usability and more better expected behavior, just a better user experience overall. So we're going to have labels attached to each of our inputs. And finally, an input of type submit. This is going to give us the submit button. The value here is going to be what's displayed on the button. This is why we don't have to worry about the screen readers here. The value is going to be what's read. It's going to say this is a button to submit. This is what the button says, and they have all the information there without having the extra label. So this button, I'm going to create a button. That button is going to say submit with a capital S. It's of type submit. That gives me that button. And then when this is clicked, that's what's going to send the HTTP request with this information, commenter and comment, with whatever the user entered, to this path using this HTTP method. I made a GET request. Twitch. The only valid methods are post and GET. You say, no, that is not. It's not what I meant. Maybe it's what I said. For an HTML form specifically, I don't know if the method can be something other than GET and post. I don't think you could do like head, put, delete. I don't think you can do those in an HTML form. I might be wrong on that, but that's what my comment was. I don't know if the other methods are valid methods in an HTML form. So this form, since we use the method GET, it's going to send a GET request. The only way we can, I shouldn't say the only way, but the way that this does get this information in a GET request is through the query string. So if I'm using this form and I enter my name of Jesse and I have a comment of good morning with an exclamation point, this is what's going to be sent to my server. So I can get this request line, I can parse this query string, and get that information from the form through this GET request through the query string. And it will URL encode, so we're going to have a plus sign. This is when I had good space morning. It'll have a plus sign for the spaces, and the %21 for my exclamation point. That's a reserved character, so it's going to URL encode that for me. So just all that gets query string stuff we talked about last week. Oh, hey, we agree. Yes. Thank you, Twitch. It feels so good. All right. So, and fair warning, this exact thing, we're not going to really do this. You can if you want, but we're not going to use GET. Obviously, this lecture is called HTTP post, and that's what the homework's all about. But we can use GET with forms here. But we don't really want to do that. So income HTTP post. Post is when users are sending us information, sending information to a server. And when we're starting to talk about forms, really that's what our forms are for, is to send information to the server. We can use GET. It will URL encode and put all those values in the query string. But we're going to have limitations there. Browsers have limits on the length of the URL. Each browser is different, different lengths of characters of limits before the browser is just going to say, no, I'm not sending your requests with that full URL, with that full tag. Some servers also are going to limit the length of the path, and they're going to send back a response. I believe it's a 413 response that says the URL is too long. For our purposes, building a server from scratch, yeah, we can get around that. We can just accept any length. But as soon as we start having a load balancer, maybe we want to put Nginx in front of our server to be able to handle the requests and then forward them to our actual server. Nginx might say, hey, these URLs are too long. So if we have lots of information being sent with a GET request in a form, our proxy server or load balancer, whatever we're using there, might start blocking our requests. We might not have that flexibility that we need. So we might get blocked by the browser. We might get blocked by our proxy servers. We might even get blocked by routers. I don't know. I shouldn't even say that. I don't know if that's a thing. But no, that can't be a thing. Routers don't even know about HTTP. And also, there's limits on the total length of the headers, the header of an HTTP request. So your request line and all headers, all the total characters of all of that before your first blank space, which separates the header and the body, that also has limits. I believe it was 2 to 8 kilobytes was kind of the consensus searching around on the browser, what the browser is going to send in the headers. So the browser is going to start blocking us in a few ways. So there's certain limitations with Git. Even if we want to just put all this in our URLs and Git requests, we're going to hit some hard limits at some point. We're going to hit these things. We're not going to have a lot of flexibility here. So what if we want to upload a file like we're going to do on Wednesday? How are we going to upload a megabyte file? We're going to hit these limits real quick. We're not going to be able to do that. So let's switch to post. So post, sending information to a server instead of requesting information like we've been doing so far. Everything so far has been, give me this information. And then we had just one thing, the query string, where it was the user sending a little bit of information, and we took that information and built a custom text response, or at least you will by Friday for that homework. We did a little bit of that, but most of it's just been, give me this file, give me your CSS, give me your JavaScript, give me this image. It's all GET requests. Now the user's going to start sending us requests, and now our requests are going to start looking like our responses in the sense that we're going to have content type and content length. So we're on the other side of this one now. Now, when you get an HTTP post request, you're looking at the content length and content type headers, reading that information and using that to figure out how to send your response back and what you should do with that information. You're reading a body of their request, not just sending a body back in your response. So you're looking for that blank line that marks the end of the headers and the beginning of the body. After that blank line, you're taking the content length and reading that many bytes after that line. That's the body. Look at the content type, which for, you're going to know, at least for homework, the homeworks, especially for homework 4, you're going to know by the path, if they're using the image upload path, you can assume the content type. I mean, in practice out there in the world, and maybe for later homeworks, you won't be able to do that. But you can assume the content type just by your path, that your front end that you built is going to send this request on this content type on that particular path. But in practice, we should be checking the content type to make sure that the browser encoded it the way that we expect. It's all the same format as our responses. Oh, I got ahead of my slides a little. So our step-by-step procedure, we get a post request. We got a request of type post. We're going to look for that. Well, we're going to check the path and all the stuff that we do with GET requests also. But we're going to check the additional steps, check that content length, look for that first blank line that indicates the end of the headers, read the content length and number of bytes, and then parse that body according to whatever type you're expecting. If they sent plain text, parse it as plain text, probably decode it as UTF-8. If it's UTF-8 text, which it most likely will be, as we'll see Wednesday, interpret it as raw bytes of a file and read that image. Like when we were sending the files in homework 3, you'll be getting files like that, just the raw bytes on Wednesday. So read all that information and then send the appropriate response. So we're doing all the things that the browser does. When you send those responses, you have your content length, content type, and the body of your response. This is all the stuff that the browser is doing with your response. Now we're on the other side of that. We're doing the same thing with these requests. We're just on the other side of the coin when we're working with posts. So let's update our form to use a post to make post requests. Oh, we just changed the method to post. Done. browser's going to take care of everything else. It's going to know what we mean by that. And now, when somebody uses this form, it's going to send a POST request to the server instead of a GET request. It's going to do probably the simplest thing that could be done. It's going to take that query string and throw it in the body. That's it. So now our path is just form-path, just the raw path. We don't have to parse any query string there. We're not looking for question marks. But now we have content length is going to be how much information, how many bytes of information we have in the body. And then the body is going to contain that same string that would have been the query string, which we call form and URL encoded. And we're going to have this content type, application xwww form URL encoded, which just means that it URL encoded the results of the form in the same way that we URL encode the query strings. Same encoding, we just get it in the body instead of in the query string. So not too different, but we are reading a content length at this point. At this point, also, I don't even want to say this, but I'll say it anyway. You could probably get away without reading the content length too. So you can almost certainly get away without reading the content type. You can also get away without reading the content length because you're just going to read everything after that blank line until the end of the request. Good question?
Yeah. I made this work for the second homework. Actually, no, sorry, the third one. Are there security issues by just putting an obtuse value in content length when you're sending stuff to the server?
Yeah.
There is, okay. Because like if I just put like something I know is going to be more than the ceiling of my content length, that's a security issue.
There is a security issue in there. I off the top of my head, I can't come up with an example attack. Because you should, so your server, besides a DOS attack, I should say, as far as like stealing people's personal information, but that can be used for a DOS attack. If your server's waiting for more bytes to read. Oh, first let me get my big but on here. You could get away with without reading the content length, but as soon as your content length is longer than the buffer of your TCP socket server, which it will be for the homework, which it will be on Wednesday when people are uploading files, then you're going to have to read the content length. So you read the content length. If that's larger than your buffer, you have to wait for the next piece of information. You have to read the next chunk of information off of your TCP socket server and then stitch together this request and then start parsing through things. So you'll stitch together this whole file. They're uploading a 5 megabyte image, stitch it all together in multiple reads off of the socket. So if somebody says, my content length's 1,000 and only send you this body, depending on how you have your server coded, your server might be sitting there hanging, waiting for more information to be read off of the TCP socket. So if somebody wants to DOS your site, just bring everything to a crawl. It shouldn't just immediately crash everybody because it'll be multi-threaded, it'll be all concurrent. So you're at that specific execution will halt, but you can still serve other users at the same time. But if they flood you with these requests and you have all of your threads waiting, depending on how your server's set up, you might have all your threads just waiting for content that's never going to come. You'll have some timeout, but you got to wait for that timeout. You can really bring down a server, bring to a crawl like that.
I'm sorry, I watched a video on something called the slow horse attack, where it'll just send just barely fast enough to not time out, so like one character, one byte.
Yeah, that would do it. That would do it. So the comment is to get around the timeout, send a character, one character or one byte at a time right before the timeout. Yeah, that's nasty. So you can really bring a server to a crawl. If you have really good concurrency, so for example, if you're doing concurrency purely through multi-threading, that's going to destroy a server. If you're using something like Apache, I don't need to get this deep into it this early in the semester, but if you're using something like Apache, which works, each request is a new thread, that's going to absolutely demolish that server. But if you're using something like Nginx, which doesn't have a new thread for each request, which has a lot of what they call lightweight threads, they have a lot better scalability in that sense. You might not be able to bring that server down quite as easily. All right. Our servers, all the servers that you'll build for your homeworks and the one I'll use as examples in class, we're going to be pretty vulnerable to that stuff. We're probably just going to completely crash our servers with a pretty simple DOS attack. We're not going to have all those advanced features built in. We'll talk about them like we just did from time to time, but we're not going to be able to protect against them. Okay, one more type of post request, or yeah, I guess, whatever. If we add this encoding type, I always want to say encryption for that. Encoding type multi-part / form - data. We can get another format, a different format of the strings that we get. So without this, that was okay. We got the query string thing. Now we got to decode, do URL decoding, which can be a pain if we're not pulling in a library to be able to, okay, % whatever, let's decode this into whatever. The plus sign is a space. This is going to give us the content in a little bit different format. We're going to get the information in this format. So now our content type, in this case we do have to read the content type, and we'll have to read the content length, especially if our buffers are overflowing, but we should read it always. And our content type is going to give us some boundary, which is going to be used to separate our data, and then each time we find this delimiter, we're going to read some information. Each chunk of information is going to have its own headers, including content disposition, which is required, and then optionally some more headers. But content disposition is going to give us the name of this field, and then the value is going to be in the body of that subpart of the body. This is what we'll have to use for file uploads. So I recommend just doing this off the bat. If you do this as soon as you're doing objective 1 on the homework, if you set it up like this, it'll save you some work when you're doing the file uploads. File uploads, this browser just won't URL encode them. It just won't. So we have to use this method if we want to upload files at all. So I recommend just getting used to this one right from the bat. Skip the GET request, skip the post without this multi-part, and just go right to multi-part. And you only have to write parsing code for one type of form post request. So just my recommendation, just jump right to this one. And we can talk about this. Let me just do it real quick, but I'll show a few examples on Monday before we go into file uploads. Just a few different types of inputs. I wanted to add this real quick because, I wanted to. But if you want those radio buttons, where you have multiple options and only one can be chosen, type radio and give them all the same name but different values. Any radio button with the same name, the browser is going to enforce that only one of them can be selected at a time. And then when we get this on the server, we're going to have some name, choose one, some key, choose one, with the value that the user selected. Drop-downs, kind of similar, but a little different setup. If we want a drop-down menu, we're going to use the select element with options for each option in our drop-down menu, and the value is going to be the value that's sent, and the name of the select is going to be the key to that value. So a little bit different setup, but same idea. If we want a drop-down, only one of these can be selected, then we can submit that value. And as always, there's all kinds of different inputs. Play around, see what you want, especially for your project. If you want color pickers, let users set the color of their username in chat, anything like that. And demos we'll get to Wednesday.